Okay, so we're going to talk about type 4 naming and its acids. Yes?
Was the type of name that I reviewed last time?
You needed to turn it in last time. If you didn't turn it in, I'm still counting it as full credit right now. Okay, guys, focus up front. Okay, so we're starting with hydrogen. So that's a big clue for type 4. It has to start with hydrogen. Hydrogen tells me it's an acid. Okay? Now, there's two types of acids. Now you want to grab out your notebook and take a little notes because not all of it is on that top of the part of the paper. The first type that we're going to talk about are binary acids. Who can tell me what binary means? Two. So that means hydrogen and something else. One other thing. Binary just means two. So when I have a binary acid, the way I name it is hydro, the base name of whatever was with hydrogen, ic, and acid. Okay? So, for instance, example, if I have HF, what would I name it? Hydro, then 4, ic, and acid. What if I had hydro, chloric acid? How would I draw that?
HCl.
HCl. H is always a plus one, Cl is a minus one, so I need one of each. Okay? So you'll notice really quickly, guess what the positive ion always is going to be on this worksheet? Hydrogen as a plus one, H plus one. That's going to be your left column all the way down. Okay? Alright, tell me what the name of this one is. Hydrobromic. Good. No. We don't capitalize for me. Okay.
Anything wrong with capitalization?
It goes back and forth. Usually we don't capitalize. We capitalize it at the beginning of the sentence, but other than that, no. Okay, binary acids. Very simple. If it starts with hydrogen and has one other element, there is one exception to the rule. But you know what it is? What's the name of that? Water. It has its own name. Yeah, that's all it's called is water. Okay?
Hydrogen.
No. You don't tell how many hydrogens there are. Okay? In any of the acids, you don't tell how many hydrogens. The hydrogens just bounce the charge or whatever it's with. So in this, we always just say hydro, whatever, ic, and acid for binary. Doesn't matter if I have 3 hydrogens or 2 hydrogens, that doesn't matter. Okay? Second type. Oxyacids. Oxyacids have to do with our polyatomics that are on the back of our periodic table. Okay? And how we name them, there's 2 different ways. Because we have 8, where it ends with polyatomics end in 8, and we have polyatomics that end in 8. So if it ended, my polyatomic ended in 8, then that becomes ic and acid. So I still name the first part of the polyatomic, but I change the ending to ic and add acid. If the polyatomic ended in ITE, then I change the ending to OUS and add acid. Now let me give you a little trick that helps me remember how to do this. I love Thanksgiving dinner, but I always eat too much. So about an hour later, I'm sick. I'm nauseous. So I ate, went into my stomach acid, ick. Okay, that's how I remember the first one. The second one, ate is when it has less oxygen, so something has been taken away, oxygen has been taken away. Well, something's been taken away from me, it makes me want to fight. Okay, that's how the ending becomes ITE. Now, how many people does it take to fight? Two of us. OS. Okay? So OUS, OS. Takes two of us to fight in an acid situation. Okay? Alright, so let's try and name these. Say that I had H2SO4. First thing I want to do is I look at the H. The H tells me it's going to be an acid. Okay, the H just tells me it's going to be an acid, so I always know if I have an H at the first, it's an acid. Then I ignore the H for this, and I look at SO4.
Wait, so what is it?
Anything that starts with an H.
H2O.
That was the exception out there, if you remember.
Sulfate oxide.
H2O has a special name, it's called water. Okay, so anytime we see H, it just tells us it's an acid with the exception of H2O. Okay, so here's my acid, I cover up the H with my hand, and I look at SO4. Find SO4 on the back of your periodic table in atomics. What is it? Sulfate is in an acid situation.
Hydrosulfate.
We actually add a little bit back here, it becomes sulfuric acid. Done. Okay, so in this one, when we have an oxyacid, we don't worry about the hydrogen. We don't say anything about the hydrogen other than say it's an acid. Okay, let's do another one. H3PO4. Okay, again, hydrogen tells me it's an acid. I ignore it, cover it up. PO4 is what I'm looking for on the back of my periodic table. What is it?
Phosphate.
Phosphate. It goes to phosphoric. So, phosphoric acid. We put the OR and the UR on the sulfate and the phosphorus. Just to make it a little bit easier to say. Okay, what happens now if I have, say, HClO2?
Hydrochlorous.
No hydro. Hydro's only for binary when I have two things. So what does the H tell me? It's an acid, so I just put an acid at the end, and I go look on my periodic table for ClO2. Can you find it?
Chloride.
Did you find it? You probably find chlorate, right? Chlorite is one less oxygen, and chlorate has the same charge.
That is elimination.
Okay? What?
Elimination.
Okay, so ClO2 is chlorite. I takes two of
Chlorus.
us to fight, so chlor plus acid. Okay? Let's go backward on a few of these now. You got this one? Let's go here. Let's go sulfuric acid. Okay, first thing, the acid tells me there's a hydrogen. Hydrogen has a +1. Sulfurous, where does sulfurous come from? Sulfite. So on the back, sulfite as well. SO3 with a -2 charge. I still have to balance charges. Have to add to equal 0. So how many hydrogens do I need to add? 2. So H2SO3. Done. Okay, let's do this one. Perchloric acid. Okay, again, acid tells me what? H, and H is a +1. Now we look at perchloric. Perchloric came from what polyatomic? Perchlorate. So look on that periodic table, what's perchlorate? ClO4, what charge? -1. So I've got +1 and -1, so I'll have to smash them together, right? Done. Okay. Now we did say in here what 8, hypo, and per-8 were, right? You got that in your notes already? Okay, so remember that when you go back, because if I had put all the possible polyatomics on the back of your periodic table, they wouldn't have been right. Okay, so remember, if I can find an 8 on the back and I need per 8, just add one more oxygen, same charge. If I need an 8 and I can find an 8, what happens? Take one oxygen away, but it's still the same charge. What if I need a hypo-8 and all I can find is 8? Take 2 oxygens away, because hypo is 1 less than an 8. So if I have 2 less oxygens, charge is still the same. Okay, so the only thing that's changing is the oxygens. Alright, so let's go and do examples here on your chart. Bring it up here. Zoom it up a little bit, maybe. Whoop, too far. Okay. Let's do this first one. What am I going to know about positive ions always here? Because they're all acids. H plus. So all the way down here, I can put H plus. Now, you don't put a plus, you're not going to get credit for it. Some of you on the other things, it says ion. If it says ion, it has to have a charge. Please make sure to put the charge. Now, hydro. What does hydro tell me? What kind of acid? Binary. It only has 2 things. Hydrogen and one other thing. What's the other thing? Chlorine. So if negative ions, just chlorine. And chlorine is one away from being a noble gas, so it's a -1 charge. So +1, -1, what's my chemical formula? HCl. Good. Okay, on this one right here, the next one down, we've got hydrogen, and it's with what? PO4, right? So my negative ions PO4, I don't even have to look on the back of the periodic table here because I know hydrogen's a +3, a +1, and I have 3 of them, that's +3, so PO4 has to be what charge? -3. Okay, and PO4 is what? You said it. Phosphate. So, what do I do with phosphate? It goes to ick, so phosphoric acid, because the hydrogen told me there was an acid. Okay, let's look at the next one, sulfurous. Sulfurous. Us was from ice. It's 2 of us to 5. So that's going to be SO, what was it? 3, what's the charge? -2. So how many hydrogens am I going to have to put with that to equal 0? 2. So H2SO3. Good job. Okay, next one. I need to find the charge. What's the charge on NO3? -1. Good. I have to put those in there. I have to put those charges in, otherwise it's not an ion. +1, -1, just smash them together. HNO3. What is NO3? Nitrate. 8 goes to ick, so it's nitric acid. Okay, bottom one. CO3. What does CO3 have a charge? -2. So how many hydrogens am I going to need? 2. H2CO3. Okay, what is CO3? Carbonate. 8 goes to ick, carbonic acid. Okay, so your job is the rest. Okay? That first column, you can go through that first column, both sides, front and back, and write H plus H plus H plus H plus, and you got half a point for each box.
So how hydrogen we're doing steering off of many.
Right, you don't know how many, but you know the positive ion is H plus. Okay? Now, while you're doing that, you're going to be having time to do that in between class, or in between presentations.